This is problem number 12 on the sample test problems for test number 1. Let h of t equal the square root of e to the t. Find possible formulas for two functions, f and g, such that f of g of t equals h of t. All right, so there are a lot of different ways to answer this question. I think there's one natural way, and that's to recognize that g of t is the inside function, and f is the outside, and so we can then come back over to the original and say, okay, in here, what's the inside function? So to me, it seems like e to the t is the inside function, and then this square root is outside. And so it's just a matter of writing that up. So we'll let g of t equal e to the t, that's our inner function, and then f of t equals, well, it's taking the square root of the inside. So is it the square root of e to the t? Actually, no, it's just the square root of t. And we can check and see that actually, if we compose those two functions and do f of g of t, that we do get exactly what we want. We get the square root of e to the t. Because this says take f of g of t, we've already decided is e to the t, that's here. And f is the function which just takes the square root of whatever you give it. So it's the square root of e to the t, which is exactly what we wanted. Now I said there are lots of different ways to do this, so this right here I would say is the best way to do it. It's the natural way, and it's going to be useful if you end up taking a calculus course to break up this function in that way. But there are other ways to do it, so we'll just write down two other quick ones. Here's a real cheesy way to do it. You can say let g of t be the identity function, just t, and then we're going to let f of t equal the whole function, square root of e to the t. Compose those and you'll see that it works, but it's kind of cheesy. G isn't doing anything, f is doing all of the lifting, so we really haven't accomplished anything, but anyway, that works. So here's a different way. This one I'll say is less cheesy, but it also doesn't really, it's not natural, like I think the way we did up above is natural. We could, for example, let g of t equal, okay, e to the t, just like we did before, but I want to make this different. So how about we say e to the t plus 7, something like that. So f of t is going to take the square root of t, just like it did before, but in this case, there's going to be a plus 7 under the square root. So how about we recognize that and we subtract 7 right away, knowing that we need to cancel that plus 7 that we put in there artificially. So there's an alternative. I don't think it's very natural, but it works.